Lecture 5, Strategic Capacity Planning for Products and Services. So this is what we're going to talk about today. We're going to talk about how capacity planning goals are tied to strategy, how to measure and define capacity, effectiveness, efficiency, utilization, capacity strategies, capacity cushion. We'll talk about bottlenecks. And then there's economies of scale and diseconomies of scale and cost volume analysis. Capacity planning. So the capacity is the upper limit or the ceiling on the load that an operating unit can handle. So there's different kinds of capacity: equipment, space, and employee skills. So the goal is to match the long-term supply capabilities of an organization and the predicted level of long-term demand. So the problem is, if you have overcapacity, your operating costs are too high. If you have undercapacity, you have strained resources and you might even lose customers. So here's some capacity planning questions. What kind of capacity is needed? How much is needed to match demand? And when is it needed? So there's some related questions. How much will it cost? What are the benefits and risk? Sustainability issues. Should the capacity be changed all at once or through several smaller changes? And can the supply chain handle the necessary changes? So capacity decisions are strategic. It impacts the ability of the organization to meet demands. It affects operating cost. It's a major determinant of the initial cost. It could involve long-term commitment of resources. It can affect your competitiveness, and it can affect how hard it is to manage things. And it's becoming more and more important due to the complexities of globalization. And you really need to plan in advance for capacity because of it takes so much financial resources and other resources. So how do you define and measure capacity? Measure capacity units that do not require updating. So if you measure capacity in dollars as the value of dollars goes up, then how are you measuring capacity there? So here's a couple of useful definitions of capacity. One of them is design capacity. So this is the maximum output rate or service capacity it's the process or operation or facility is designed for. The effective capacity is really the design capacity minus allowances for personnel time, maintenance. There's different things that just sort of take away from that design capacity. So here's some measures. The actual rate output. This is the actual output that is achieved, and it cannot exceed the effective capacity. If you get more output than the effective capacity, you're not measuring the effective capacity properly. Efficiency. So efficiency is defined as the actual output divided by the effective capacity. And then utilization is the actual output divided by the design capacity. So, and both of these are measured as percentages. So here's an example. You have a shipping department or a shipping dock, and it's designed to handle 50 trucks a day. So what you can really get out of it is 40 trucks per day. So that's your effective capacity. And then your actual output is 36 trucks per day. So the efficiency is the actual output divided by effective capacity. So that's 36 divided by 40, 90%. So you're 90% efficient on this. Utilization is the actual output divided by the design capacity. So the utilization is 72%. So there's different determinants of the effective capacity, things like facilities, product and service factors, process factors, the people, policy, operational factors, your supply chain, and external factors. So all of this sort of comes into your effective capacity. So the strategies are typically based on assumptions and predictions. And so this is what's the long-term demand patterns, what technological change are we expecting, and what's your competitors doing. Capacity strategies. So one capacity is called leading. And this is where you build capacity in anticipation of future demand increases. The second is what's called following. So you don't build the new capacity until your demand exceeds your current capacity. And then the next one is tracking. It's very similar to the following strategy, but it adds capacity in relatively small increments to keep pace with the demand. Capacity cushion. So the capacity cushion is the extra capacity that you have to offset the uncertainty in your demand. So the capacity cushion is 100% minus utilization. So there's a couple of strategies you can have with capacity cushion. Organizations that have greater demand uncertainty typically have greater capacity cushion, and organizations that have standard products and services that generally have a smaller capacity cushion. So if you have a lot of uncertainty, you want a larger one. If you pretty much know what's going on, you can get by with a smaller one. Forecasting capacity requirements. So you have long-term considerations to the overall level of capacity requirements. So a lot of times your capacity takes time to build. If it's a new building, that takes time to build that. That could be years. If it's new machinery, you have to order and install the machinery. So there's some kind of time horizon, and you have to forecast this and convert that into capacity requirements. So short-term considerations relate to the variations in capacity requirements. It's less concerned with cycles and trends than with seasonal variations and other variations from average. Service capacity planning has several challenges. First is the need to be near customers. And then the second challenge is you can't store services. And then you have that degree of demand volatility. So there's some demand management strategies. Strategies can be used to offset capacity limitations, and that are intended to achieve a closer match between supply and demand. So you can have pricing, you can have promotions, you can have discounts, and you can have other tactics that shift demand from slow peak periods or to slow peak periods. So we have one of our favorite restaurants. We're part of the loyalty club where you get a free hamburger every 10 that you buy, and they send us emails, and the emails they'll say Tuesday there's this special. Now the interesting thing with those emails is because they're emails, they can adjust that up and down very quickly. So if they're, and they can control the number that they send out. They seem to come to me randomly, but they can increase that number. Let's say that they know that if they send out 200 emails, they'll get 5 extra customers. And so then you can sort of forecast and say, well, we have the capacity on Tuesday night for this many customers, so I'm going to send out 200 emails with 5 more customers or something like that. So you can especially with the electronic promotions, you can actually be pretty sophisticated with some of these marketing techniques. In-house or outsource. So once you determine your capacity requirements, the question is, are you going to do it yourself or are you going to outsource it? So some factors to consider are available capacity expertise, quality considerations, the nature of the demand, the cost, and the risks. Bottleneck. We're going to talk about bottlenecks a lot throughout this course, but conceptually, if you think of a bottle, there's the neck of the bottle. You can't pour out any faster, liquid out of that bottle any faster than that bottleneck. So here you have 4 different operations, and they each, you have the capacity in each of these to create 10 widgets per hour. But then you come to this bottleneck operation where they all have to go together and you can only do 30 per hour. So in this case, the bottleneck is 30 per hour. So optimal operating level. So this is a concept where if you have an average cost per unit so this is cost per unit, and then this is the rate of output. So over here, if you're just making one of these, it's really expensive. But as you make more and more of them, the cost continues to go down. But at some point, the cost actually starts going up. And this might be you have full shift workers, and then over here you might have to start paying overtime or something, hire another shift, and the cost starts going up. So there's economies of scale, and this is where the output rate is less than optimal level, and as you increase your output rate, it decreases the average per unit costs. So the reasons for economies of scale is the fixed costs are spread over a larger number of units. The construction cost increase or decreasing rate as the facility size increases, and processing cost decrease due to standardization. Then there's something called diseconomies of scale. We don't hear about this very often, but if your output rate is more than the optimal level, increasing the output actually increases the average cost or average unit cost. So there are several reasons for diseconomies of scale. Distribution costs could increase due to congestion or shipping from a centralized facility. Complexity increases cost. Inflexibility can be an issue. And as you get bigger, you can get additional layers of bureaucracy. So here we have these scales, and you think about the size of the plant. So here you have the average cost per unit and then the output rate. So you have a choice. Am I going to build a small plant? Am I going to build a medium plant? Am I going to build a large plant? And this is where you really have to forecast your demand. So if you think your demand or output demand is somewhere in this range right here, you probably want to build a small plant. But see this crossover point here? So any demand greater than this, you want to build a medium plant. And then over here, if you're fairly certain that your demand is going to be over here, then you want to build a large plant. We'll go into this in a little more detail. So constraint management. So when you have something that limits the performance of a process or a system, that's a constraint. So there's different kinds of constraints. One is your market. If you've saturated the market, that's a constraint. There's nothing you can do, or you have to do something to eliminate that constraint. You can have resource constraints. Let's say that you're dependent on some product that you get from a supplier and you can't get more than some amount of that. You have material constraints. You can also have financial constraints. If you're a small company, you don't have enough capital. Maybe your demand is forecasted to be for a medium plant, but all you can afford is a small plant. Knowledge and competency. Maybe you have 10 workers, one of them knows everything and the other 9 don't know it very well. Policy. You can have internal policies, external policies that can constrain your production. Resolving constraint issues. So the first thing is to identify the most pressing constraint. Where is your biggest bottleneck? And then change the operation to achieve maximum benefit given the constraint. So you focus on that constraint and you say, how do we maximize the efficiency of this constraint or eliminate that? And then make sure the other portions of the process are supportive of the constraint. And so you explore and evaluate ways to overcome the constraint. And then once you've eliminated that constraint or lowered it, there'll be a new constraint. And so then you repeat this process on the new constraint. We'll talk about this later, but there's something called the Pareto principle. It's the 80-20 rule. So 80% of problems come from 20%. So that you use this Pareto principle to find your constraint and you focus on that, and then you keep working on the next constraint. Evaluating alternatives. So there's several techniques for evaluating your alternatives. You can do cost volume analysis, you can do a financial analysis, you can do decision theory, you can do waiting line analysis, you can do a simulation, all of these. So we're just going to go into detail on that first one, cost volume analysis. So this focuses on the relationship between cost, revenue, and the volume of output. So the first thing is fixed cost, or FC. And so this is, the fixed costs are really the cost regardless of volume. So this is your some fixed cost examples are your capital expenditure. So you bought a machine, you got a building, and so that's a fixed cost. No matter how much you, no matter what the volume is, you have to pay for your building and your machine. And you need a manager and people that are just sort of there all the time. HR, you have to have HR. Then there's variable costs, and the variable costs are related to volume. So this is might be your employee cost. It could be the raw material cost. Those things that every time you add a unit, that's a unit cost. And then the total cost is simply your total cost equals the fixed cost plus the variable cost. Total revenue is the revenue per unit times the quantity. Then the break-even point. The break-even point, here's the mathematical formula. It's total revenue minus total cost, and you get into details of each of these. The price, the revenue, times the quantity minus the fixed cost plus the quantity times the variable cost. Multiply that all out, and you end up with the break-even point. It's a little easier to see graphically. So here we have the volume of units and then the dollar amount. And there's two lines here. One line here is the fixed cost. And then you have the total variable cost. So as you do more and more units, your variable cost goes in. So the total cost is the variable cost, which is this line, and the fixed cost, which is this line. You add those two lines together and you get this line right here. Now you have your total revenue, and this is if you sell this many units at this price, this is the more units you sell, the more you get. So now you can look at this. Here's the total revenue, and then you have this total cost curve, and you put them over the top of each other. Right here is the break-even point. So back here, you're operating at a loss, and over here you're operating at a profit. So ideally you want to be above the break-even point. So you can also look at this as a loss and profit curve, where you have the break-even point, you're losing money here, you're making a profit here. Excuse me. You can also look at profit from alternative A and profit from alternative B. So here, this is the point of indifference. So at this volume, alternative B and A are the same. So if you're going to lose money, alternative B is better. If you're going to be making a profit, alternative A is better. So you take all of this together and you can get volume cost relationships. So you have stepped fixed costs and variable costs. So you have this thing here where you have one machine. The fixed cost is right here. So here's your total cost. If you have two machines, this is the fixed cost, and here's your variable cost. If you have three machines, you go like this. So now you take this graph, these costs, and you plot the total revenue across here. And you see right here, if you have one machine, you're going to be losing money, even if you have that machine fully productive. If you get to two machines, you have a break-even cost right here. You start making a profit here. If you have three machines, you have a break-even point here, and you start making a profit here. So in this case, if you can get this kind of quantity sold, then 2 machines is good. If this is all your market will handle, maybe this is the wrong business to be in. If you can only do this. Another consideration here is if you could outsource this where they're selling things to other customers and you can get that break-even point to a reasonable level where they may be able to, your subcontractor or your supplier may be able to get this economies of scale up here. But a strategy here could be, if you're not sure what the quantity is, go ahead and get 2 machines, and then as your quantity or demand goes up, you get to this point, you install a 3rd machine. So in this lecture, we've talked about capacity planning and how the goals are tied to strategy. There's methods for measuring and defining capacity, effectiveness, efficiency, utilization, some capacity strategies, the capacity cushion, bottlenecks, economies of scale and diseconomies of scale, and then cost volume analysis.